Assalamu alaikum. I am Dr. Abdul Wahab, Associate Professor, Department of Pharmacy, Guwahati University of Science and Technology. I am course instructor for the subject dispensing pharmacy, and our today's topic is solution and extemporaneous dispensing of solution. Solution and extemporaneous dispensing of solution. I know that you have a background knowledge about the solution because you have already studied in your previous semesters, like in pharmaceutical preparation and similarly in physical pharmacy. But today we will be discussing about the extemporaneous dispensing of solution. But before going to discuss the extemporaneous dispensing of solution, I would like to brief you about the solution, that what is solution, what are the different types of solutions, what are the different properties of solution. So as you can see over here in discussion outlines, first of all we will try to discuss about the solution, and then the different types of the solution, properties of solution, extemporaneous dispensing of the solution. So first of all, what is solution? A solution as defined is a homogeneous mixture of two or more components. It is a homogeneous mixture of two or more components. The simplest solution consists of two components: a solute, which is dissolved in a solvent. So we can say that the solution consists of two components. One is solute and the other one is solvent. The solute and the solvent could be in the solid, liquid or gaseous states of matter. So these are the different states of the matter, like solid, liquid and gases. So the solute and the solvent could be in these different states of the matter. Most commonly, pharmaceutical solutions are preparations in which the solid solutes, for example, drug and excipients, are dissolved in a liquid solvent system. So in pharmaceutical solution, mostly drug and different other excipients which are used for the formulation, for the designing, for the preparation of the different dosage form, which are dissolved in the liquid solvent systems. Example, in a saline solution, salt is the solute. As we discussed, that solution consists of two components. One is solute and the other one is solvent. So similarly, in this example, in a saline solution, salt is the solute which is dissolved in water, and over here the water is the solvent. So in saline solution there are two components. One is salt and the other one is water. So in which the salt is dissolved in water and the water plays a role of the solvent of the vehicle. Other examples of the solution examples, as you can see over here, any two substances which can be evenly mixed may form a solution, even though materials of different phases may combine to form a solution. The end result always exists of single phase. In solution, there must be single phase. If we are going to combine to different component, like as we have discussed, that solution consists of two component. One is solute and the other one is solvent. But the final form of this combination must be of single phase. Solid solution, example is broth. These are the example of different solutions. So we can say the solution may be in solid form, like you can see over here in this example. It is the example of solid solution. It is broth. Similarly, liquid solution, example is aqueous hydrochloric acid, HCl in water. Similarly, gaseous solution, The example is air. So these are the different form of the solutions. So characteristics of a solution. Characteristic of solution. A chemical solution exhibits several characteristics. A chemical solution exhibits several characteristics, like a solution consists of a homogeneous mixture. A solution consists of a homogeneous mixture. A solution is composed of one phase, for example, solid, liquid, gas. Similarly, particles in a solution are not visible to the naked eye. It is the characteristic of solution that the particles in a solutions are not visible to the naked eyes. Similarly, a solution does not scatter a light beam. A solution does not scatter a light beam. Component of a solution cannot be separated using simple mechanical filtration. Component of a solution cannot be separated using simple mechanical filtration. A solution is stable as compared to other liquid form, for example, emulsion, suspension. So in all these, solution is a stable one. Different types of solutions. On the basis, first of all, we will give the different types of the solution on the basis of the amount of solute added. On the basis of the amount of solute added, for example, depending upon the resolution of solute in the solvent. Solutions can be categorized into supersaturated solution, unsaturated solution, and saturated solutions. So these three types of solutions are on the basis of the amount of solute added. So a supersaturated solution comprises a large amount of solute at a temperature wherein it will be reduced. As a result, the extra solute will crystallize quickly. Understand? The extra solute will crystallize quickly. Similarly, an unsaturated solution is a solution in which a solvent is capable of dissolving any more solute at a given temperature. An unsaturated solution is a solution in which a solvent is capable. That solvent which is used for the dissolution of the solute is capable of dissolving any more solute at a given temperature. While in case of saturated solution, a saturated solution can be defined as a solution in which a solvent is not capable of dissolving any more solute at a given temperature. But in case of unsaturated solution, the solvent is capable of dissolving any more solute at a given temperature, while in case of unsaturated solution, the solvent is not capable of dissolving any more solute at a given temperature. Understand? Similarly, so the different types of solution on the basis of water as a solvent, the solutions are of two form, depending on whether the solvent is water or not. If the solvent is water, aqueous solution. In aqueous solution, when a solute is dissolved in water, the solution is called an aqueous solution. So in this case, if solvent is water, if we are using the salt water for the dissolution of the solute, so to this type of solution, we can use a term aqueous solution. For example, salt in water, sugar in water, and copper sulfate in water. So these are all aqueous solutions. Non-aqueous solution, when a solute is dissolved in a solvent other than water, it is called non-aqueous solution. For example, iodine in carbon tetrachloride. Over here, For the dissolution of the iodine, carbon tetrachloride is used. If we use carbon tetrachloride for the dissolution of iodine, so for such type of solution, we can use the term non-aqueous solution. Similarly, sulfur in carbon disulfide, phosphorus in ethyl colo. So in all these cases, for the dissolution of the different solute, water is not used. So therefore, we use the term non-aqueous solution. On the basis of amount of solute and solvent added. Type of the solution on the basis of amount of solute and solvent added. As discussed, solutions are having two components, the solvent and the solute. Solution depends on the amount of solute added to the solvent. Solution depends on the amount of solute added to the solvent. A dilute solution contains a small amount of solute in a large amount of solvent. In case of dilution, in case of diluted solution, the amount of solute will be small and the amount of the solvent will be large. A concentrated solution contains a large amount of solute dissolved in small amount of solvent. It is opposite to dilute solution. In concentrated solution contains a large amount of solute dissolved in small amount of solvent. Homogeneous and heterogeneous solutions. Homogeneous and heterogeneous solutions. Homogeneous solutions are solutions with uniform composition and properties throughout the solution. For example, a cup of coffee. For example, a cup of coffee, it is homogeneous solution. Perfume, it is homogeneous solution. Cough syrup, it is homogeneous solution. A solution of salt or sugar in water, etc. These are all homogeneous solutions because in this case the composition and properties throughout the solutions are uniform. Heterogeneous solutions are solutions with non-uniform composition and properties throughout the solution. A solution of oil in water, it is heterogeneous solution. Similarly, water in chalk powder, it is heterogeneous solution. Solution of water and sand, it is also heterogeneous solutions, etc. On the basis of Raoult's law, how can we classify the solution? On the basis of Raoult's law, liquid-liquid solution can be of two types. They are ideal solution and ideal solution, and non-ideal solution. Ideal solution and non-ideal solution. So these two category of solutions are on the basis of Raoult's law. What is Raoult's law? In 1986, it was a French chemist, Francois Marty Raoult, who proposed a relationship between partial pressure and mole fractions of volatile liquids. According to the law, the mole fraction of the solute component is directly proportional to its partial pressure. So it is basically Raoult's law. According to the law, the mole fraction of the solute component is directly proportional to its partial pressure. No, ideal solution. According to Raoult's law, the solution which obey Raoult's law at every range of concentration and at all temperature are ideal solutions. We can obtain ideal solution by mixing two ideal components that are solute and solvent having similar molecular size and structures. So in this case, the molecular size and structures of both solute and solvent must be similar. For example, consider two liquids A and B and mix them. The formed solution will experience several intermolecular forces of attraction inside it, which will be A and A intermolecular forces of attractions, B intermolecular forces of attractions, AB intermolecular forces of attraction. So these are the different intermolecular forces of attractions. If we are going to mix two liquids A and B, and the formed solutions will experience several intermolecular forces of attractions as mentioned over here. So the solution is said to be an ideal solution only when the intermolecular forces of attraction between A and A, B and B, and A and B are nearly equal. Nearly equal. If all these attraction intermolecular forces between these two liquids are nearly equal, then we can say to such type of solutions an ideal solution, and the solution will be an ideal solution. Examples of ideal solution: n-hexane and n-heptane. If we are going to mix these two liquids, so the formed solution will be an ideal solution. Similarly, bromoethane and chloroethane, the combination which is obtained by mixing of these two liquids, we can obtain the solution an ideal solution, and the end product will be an ideal solution. Characteristic of an ideal solution: they follow Raoult law. This implies that the partial pressure of the components A and B in a solution will be PA is equal to PaO XA and PB is equal to PbO XB. PaO and PbO are respective vapor pressure in pure form. On the other hand, XA and XB are respective mole fractions of component of A and B. The enthalpy of mixing of two components should be 0. So in this case, in case of an ideal solution, the enthalpy of mixing of two components should be 0. That is, lambda max H is equal to 0. This signifies that no heat is released. This signifies that there is no release of heat or absorptions of heat during mixing of two pure components to form an ideal solution. The volume of the mixing is equal to 0. That is, lambda max there is mix volume V is equal to 0. This means the total volume of solution is exactly same as the sum of the volume of solute and solution. Adding further, it is also signifies that there will be concentration or contraction or expansion of the volume while the mixing of two components is taking place. The solute-solute interaction and solvent-solvent interaction is almost similar to the solute and solvent interaction. Non-ideal solution: the solution which don't obey Raoult law at every range of concentration and at all temperatures are non-ideal solution. Non-ideal solutions deviate from ideal solution are also known as non-ideal solution. Example: acetone and carbon disulfide. The solution of acetone and carbon disulfide, it is non-ideal solution. Acetone and benzene, it is also non-ideal solution. Chloroform and benzene, it is also non-ideal. So similarly, chloroform and diether, these are all the non-ideal solutions. Characteristics of non-ideal solution. The solute-solute and solvent-solvent interaction is different from that of solute-solvent interaction. While in case of ideal solution, it was not different. It is similar. The enthalpy of mixing, that is H not is equal to 0, which means that heat might have released if enthalpy of mixing is negative, as you can see over here, or the heat might have absorbed if enthalpy of mixing is positive, as you can see over here. The volume of mixing, that is volume V is equal to V, which is not equal to 0, which depicts that there will be some expansion or contractions in the dissolutions of liquids. Properties of solution. Physical properties of solution. Properties of solution. Additive properties, colligative property, and constitutive property. So these are the different properties of solution. The first one, additive property. The physical properties which depends upon sum of properties of all constituents is called additive property. For example, mass, volume, molecular weight. Similarly, colligative property, the physical property which depends upon number of particles of solution is called colligative property. For example, elevation in boiling point, lowering in vapor pressure, freezing point depression, and osmotic pressure. I don't want to go into detail all about these properties because you have already studied about these properties in pharmaceutical preparation and physical pharmacy. Constitutive properties. The physical property which depends upon arrangement of atoms in molecule is called constitutive property. For example, refractive index, solubility, and viscosity. Now I'm going to discuss about the extemporaneous dispensing of solution. As you can see on this formulation, choline mixture with pectin, it is the example of extemporaneous solution. That how can we prepare, how can we compound choline mixture with pectin, and then how can we dispense such type of dosage form. So you can see over here in this dosage form, in this mixture of solution in formula, there are given different component and like Vegam, the quantity according to this formula, that is 0.88 gram, sodium carboxymethyl cellulose 0.22 gram, purified water 79.12 gram, choline 17.50 gram, pectin 0.44 gram, saccharine 0.09 gram, and glycerin 1.75 gram. So these are the different components which are mixed if we are going to prepare the choline mixture with pectin. So in preparation, first of all, add Vegam and sodium carboxymethyl cellulose to the water with continuous stirring. What should we do? We should do, first of all, add Vegam and sodium carboxymethyl cellulose to the water with continuous stirring. Then add the mixture of choline, pectin, saccharine, and glycerin, and then after mixing of all these components, and add to the suspension of Vegam and carboxymethyl cellulose. After mixing all these, what should be done? We should add all the mixture of all these components into the suspension of Vegam and carboxymethyl cellulose. After that, a preservative and flavoring agent may be added to the product. What should be the dose for this mixture of kaolin and pectin, the dose is 5 ml TID, tars in dye, 3 times a day. Label, what should be written on the label? Shake well before use. Uses is it is used as antidial. There is one another extemporaneous solution or mixture, that is like you can see over here, compound sodium chloride mouthwash. Sorry. A mouthwash is an aqueous solution with pleasant taste and odor, used for rinsing, deodorant, refreshing, or antiseptic action. As you can see over here in this formula, that how can we prepare sodium chloride mouthwash. So these are the different agents, different components which are used for the preparation of sodium chloride mouthwash. Sodium chloride 2 gram, sodium bicarbonate 1 gram, MRN solution 2 ml, and peppermint water QS sufficient quantity to make the final volume 100 ml. Preparation: dissolve the weighed quantities of sodium chloride and sodium bicarbonate in 3/4 of vehicle. Over here the vehicle is peppermint water, and then add MRN solution and incorporate more of the vehicle, means peppermint water, to produce the required volume. Then transfer to a bottle and label the bottle and dispense. Uses: it is used to cleanse and deodorize the buccal cavity. Dose: rinse the mouth 3 to 4 times daily as required. Label: dilute with an equal volume of warm water before use, not to be swallowed in large amount. Similarly, it is another example of extemporaneous solution, that is enema. Enemas are aqueous or oily solutions or suspension intended for introduction into the rectum for their purgative, sedative, anthelmintic, anti-inflammatory, or nutritive effects. They may also be used for X-ray examination of the lower bowel. So how can prepare the simple enema? It is the formula for the enema: soft soap 25 gram and purified water 500 ml. How can we prepare? Method of preparation: dissolve the soft soap in purified water and then transfer to the container, label it and dispense it. Uses: it is used as a coagulant enema. So thank you so much. It was all about the solution and extemporaneous dispensing of solution. In our coming lectures we will try to discuss about the emulsions, suspensions, suppositories, and creams, ointments, and their extemporaneous mixtures in detail. So God bless you. Thank you so much.